All right, y'all. Welcome, welcome, welcome. We're going to get started here. We're talking about some more data types today. Last time we talked about the scalar types. We talked about ints. Let me bring this music down just a little bit. We talked about ints. We talked about floats. We talked about um, booleans. We haven't talked about strings yet. We talked about characters. Strings are going to be fun. Just so everybody's got the link, we're working on section 3.2 in the Rust book. You can always find that online for free. Hey, just a quick shout out to the GROM's Club NFT project. That's who's putting this on. Me, my team. We're doing this. Um, Come check us out. Men of GROM. It's a Solana NFT, so you can go to phantom.app and get your Solana wallet. Get a little soul in there. It's half a soul. It's a heck of a deal. At our regular site, groms.club, you can see our Discord links. You can see our Twitter links, and in Discord, you can come learn Rust with us. You can learn about Solana program, about NFTs. You can learn about Solana. We're just a community of learners. Eventually, we're going to have some exclusive channels for GROM holders, so you'll want to have one when that goes up. That way, you can have full participation. But the Rust streams will always be available to anyone, right? Because this is how we do Rust. The Rust book is free. The Rust language is free. I'm just learning with you guys, and I enjoy sharing my knowledge and sharing what I've learned. All right. So compound types are basically any type that can hold multiple values, right? All the types we talked about last stream or video were scalar types, and those are just one value, right? So you could obviously have like 500, that's multiple numbers in a value, but that's still like multiple digits, but still one value, right? With compound types, that's not the case. Give me just a second here to clear my throat. Yeah, with compound types, we can hold multiple values in one type, and that becomes really helpful. Once you start building out programs that you don't want to just be limited to one value per variable. So the first one we talk about is the tuple, and I'm copying to be clear. There's nothing fancy going on here. Um, Sorry, I forgot I didn't have my Vim bindings here. Um, there's nothing fancy here. I'm just copying the uh, excuse me, I can't type the book code and then explaining it best I can. So a tuple can hold different values of multiple types. And so here we're explicitly we're explicitly what's the word? Man, we're explicitly declaring what the data type is for each individual character, right? And so you see, like the first position here, it maps to the second position. The first position here, and this parentheses maps to the first position here. Second position here maps to the second position here. The third position here maps to the third position here. So um, we don't have to indicate the types. We can let Rust infer the types this way. And so what does inference mean? Inference means that Rust is going to do its best, the Rust compiler is going to do its best guess to determine what data type these variables should be. And if you notice, they're a little different than what we typed up here. These are two different variables. Here we defined that we wanted this first value to be an I32. That's a signed integer, 32 bits. And remember, signed just means that it can be a negative number. F64 is a floating point type of 64 bits. You know, so when we see this decimal, we know we need a float of some kind. And then a U8 is an unsigned integer type. So if this was a negative, this would be a problem. And I think this should give, you know, if Rust, see, Rust has a problem with that. See, it's telling, and now this is the feedback from my Rust analyzer that we installed in the Rust and Chill video. Go check out that on YouTube. It's telling me that this doesn't work, right? And basically that's because it's saying, hey, this should be, you declared this as an unsigned integer and you have a sign, so that doesn't work. So if I take away that minus, you know, it's okay with that, right? Okay, so this tuple is inferred. The Rust compiler has gone in and guessed what it thinks will be the best data type for your values that you've entered here. Now just remember, these variables in the gray are not the data types in the gray font have not been typed by me. This is information that the Rust Analyzer extension in the Visual Studio Code IDE has given me. It's just showing me that information. Just because so Rust Analyzer is, you know, working with Rust compiler to determine this information. So you know, most of these variables are the same except for this U8, right? The Rust compiler makes a decision that a U8 is not a good default integer type because I guess it doesn't know if maybe down the road you want to either one, make it a negative number, or two, make it a bigger number than an 8-bit data type can hold in the memory. Okay, so with tuples, we have a couple of ways that we can work with them, and this one's actually, I think this is cool. To me, it was kind of new to learn about how this works when I first learned about it. So let me type this out and then we'll talk about it. So I just want you to notice that, like, when I didn't have this typed, there was no inferred data type here. When I didn't have that tup variable typed in there, but as soon as I did, Rust knew exactly what data types they were because they're up here, right? So what I think is really cool about this is, like, so this is a concept called destructuring. And you may have seen this, you know, one way that I remember from JavaScript is, you know, if you have modules, multiple modules, and you want to pull those out of a of a class or something like that. I don't know if that's the right word, but you destructure them. And so here I'm destructuring this tuple variable. So what's happening is, knowing that this tuple, it has 3 values in it, I can take them out and sorry for that noise. I need to figure out my notifications. The tuple, sorry, I'm going to start over with destructuring. So knowing that this tuple holds 3 values, the Rust compiler understands that when we put 3 variables in these parentheses, it knows to map those values in that tuple to the variables we provided. And it's being destructured using pattern matching. And so all that means is that it's going to take this first variable, this 500, and match that to the first value. Or excuse me, I said that completely backwards. It's going to take this first value, 500, and match it to this first variable, x. And then it's going to take the second value, just like in match the types, right? It's going to match that that value here to this y variable, and this one type here to this z variable. I hope that makes sense. Yeah, but that just makes them easy to work with. Another way you can work with tuples is to pull them out individually using a dot. I don't know if it's a decimal point to address the different positions. So we're gonna do. I'm actually gonna use that tup inferred variable just to show that can be used as well, and we can stop getting a warning that we're not using it. All right, so you may already see some. If you're new to programming, you may already see something weird with that last line, and we'll talk about that. In just a moment. Okay, so it's tup inferred, right? We know that variable is up here. Let me save this. I'll get out of here. So we know that tup inferred is this variable up here, and we know that 500 is this first value, right? And we're saving 500 to this variable called 500. And we're getting the first one, right? But here I have a 0. So what this is called zero-based indexing. And all that means is that as we count the positions in this data structure, this tuple, we start with 0 and work our way up. So the value in position 0 is 500. The value in position 1 is 6.4. The value in position 2 is 1. And you can see that illustrated here. Okay, so that's zero-based indexing. You're going to see that all over programming, so you want to kind of get used to it. Yeah, and it's nothing more than understanding that you start with 0 as the first position instead of 1. Okay. So that's pretty much it for tuples. I think that's important for now. I guess what we can talk about is like these are called. So one thing it mentions in the book I'm seeing here is these are called indices, or remember we said this is a zero-based index. These individual numbers here are called indices. So 0 is an indice that points to the first position. 1 is an indice that points to the second position. 2 is an indice that points to the third position. And I should actually, sorry, I'm messing up here. I should actually be pointing to this variable because it's the one we're referring to. They happen to be the same values, but these are 2 different variables. So apologies for not being clear there. Tup inferred is this value. So the zero-based index, this 0 indice, the indice 0 is this 500 here, right? This indice 1 is the second position, 6.4 here. This indice 2 is a third position, 1 here. Okay. Okay. So let's go to the array. We're going to talk about arrays now. So arrays are another compound type. They're a little different than maybe what you've seen in Python and JavaScript languages like that. And I was tripped up over this too. Is that so we'll talk about it we'll probably talk about it more, but just to kind of give you a kind of heads up is like typically with arrays, I've done some like data science, deep learning work, not work, but just kind of learning on my own, understanding how that works. And with Python, you use arrays and different data frames and things like that a lot. But even just like your simple arrays, they you manipulate them a lot, right? Especially in data science work. You change the numbers, you update them, you remove numbers, you cut them, you split them, you splice them, whatever, right? But arrays are fixed length. So we're not going to get into them today, but a lot of the times that you would use arrays in Rust that you would normally sorry, why you should use the sorry, hey Kogu, yeah, I'll see if I can talk about that towards the end. Who wants to go more into tuples? Yeah, thanks for the question. So arrays are like more they're fixed length, and so what you would use is a vector if you want to be able to like change the length of the data type. The way you would normally use those in JavaScript and Python, you would want to use a vector instead of an array. Okay, so just the hang on a second. I got to do some quick window management. I want to be able to see questions that come in, and I don't have my windows set up very well. Apologies for that. There we go. Okay. So with arrays, like I think what a good way to think about them is that they're kind of like you want to use them when your use case is much more kind of static, right? And a good example they give is like if you had a program, like a calendar program, or something you needed to, and I'm just going to copy because it's kind of ridiculous for you to sit here and watch me type this up. I just got the whole function. Sorry. I'm going to clean this up some. So this is a good use case for an array, right? We have these like the year. So the months in a year are pretty fixed, right? Like they're not going to change really ever. So it makes sense to like, hey, we have this data here, and then like later on, I want to say months 0. Okay, and then this is not my birth month, by the way, or maybe it is. And so, right, and then let's say Kogu's here, so I'll say let I always want to make sure if I got that spelled right. And I don't know, Kogu is watching the stream right now. I don't know his birthday, so I'm just making this up to be clear. I really need to install. I can't believe I didn't install Vim by. I'm just like, it's crazy how much I'm struggling to type. It's really like throwing off my concentration. And I'm not very good at Vim. Okay, so like now we have this little program that tells us the birth, my birth month, my fictional birth month, and Kogu's fictional birth month. So I never need to change this array in order to use it, right? So quick couple notes, right? We still use zero-base indexing in with arrays, except our syntax is a little different, right? We use these brackets or braces rather instead of a dot like we did a tuple. Kogu, your question like has me thinking. I'm trying to like at the same time I'm doing this, I'm trying to. Oh, he said June. All right, let me change that. That was going to be so zero-base indexing, right? So I'm like not sure, right? So that's 0, 1, 2, 3, 4, 5, right? Except I didn't mine. Still. We'll go ahead and run this using Rust Analyzer up here to run it. Yeah, so this is what we have. I was born in the month of January, right? 0, first indice, January, 5th indice, June. All right, pretty straightforward. So our array have to be all of the same type. We can't have an array of different types like we could tuples. I mean, I think that's probably the defining characteristic of an array versus a tuple. Yeah, so I skipped over how, as I was using this example of how to explicitly declare types. So again, we have some type inference here. The Rust compiler via Rust Analyzer is telling us that this is a string slice type, which we'll talk about. We might spend 2 videos on strings and string slices. And the length of our array is 12. So there's 12 months in our array. So that's right. We have the right amount of months. But yeah, so maybe like you want to make sure you have a specific type and length. This is how you do that, and we'll just. I'm actually gonna since chances are I want to test this out. So I believe, yeah. So the Rust compiler, since I didn't provide a type, it infers that these are I32s. So just to be explicit, let's do a I8, and we'll do 5 or oops. Yeah, and so I'm explicitly declaring this array using the data type that I want in here and the length of the array. So I can just go in here and just to show that, if we have some kind of type, issues. So me adding these dot zeros or turning these variables into float type C F64 is what Rust is. The Rust compiler is inferring. And it stops right here. It doesn't even check these. That's interesting. So it's going to tell us right here, this first value in the 0 indice is a problem. We're expected a assigned integer of 8 bits, but they actually found a floating point number. So that's just showing our, if we indicate a specific type, Rust will say no. So one thing I should say when we do this, if ever we see this red squiggly, I could run this and it's going to have us a problem. It's going to give us the same problem here. Just to save time, I don't always run these, but anytime we see a red squiggly, I believe that's always going to, almost always. There may be some exceptions, but almost always when you see a red squiggly, it won't compile. But yeah, I'm not feeling so sure about that. It's possible we may see some red squigglies at some point that the program will compile just due to maybe some like misunderstanding of the state of things by Rust Analyzer. I don't know. I feel like I've seen that. It's the only reason I'm kind of hesitant to say um, that's guaranteed. Um, so this program's interesting. It's worth running. That they have a little program they have in the Rust book. I'll just bring it in and paste it and just talk through it real quick. Used to be all of this, I believe, should be yeah. None of this is new to us except for maybe this U size, which um, yeah, I don't know if we can talk about that today. We should have talked about those variables. That's okay. Yeah, so let's just go through this real quick. We're bringing in our standard library, our Rust standard library in the input output module, which remember, this is just code that comes along with whenever you install Rust on your machine. The standard library gets installed, and you don't always use it, so you don't always necessarily have to bring it in. But when you do, this is how we do it. And input output is just like, it helps us. Well, we'll talk about it. It helps us get input from the user. Our functions, we know. We'll go into depth in the next stream happening tomorrow about functions. We're declaring an array here. We have a type inferred array that's inferred to be I32 by the Rust compiler, length of 5. Please enter an array index. That's just a prompt on the output. Excuse me. We're creating an index string, and we're reading that in from the user. We're parsing that string that we got from the user up here. We saved it right here. We're trimming off any like line breaks or extra characters we don't need, and parsing it to a U size, which is essentially a type of number. I think that's enough. We can talk about it for now. And then we have our error handling in case that doesn't work out. And then so this is creating a new variable that is taking our array we created up here and using that index the user entered and to pull out that element, right? So if I put a 0 here when it asks me, I should get a 0, which would be 1. And then we're just printing this out using our placeholders. We haven't seen these 2 placeholders yet, I don't think. So that's worth noting. We have 2 placeholders, and then we're just using commas and the variable names to indicate the order in which they get printed out in these placeholders, right? So index will map to this placeholder, element will map to this placeholder, right? All right, so we're gonna go ahead and run this. I'm gonna use my handy dandy button here that Rust Analyzer gives me. And just so you know, this is just cargo run. In fact, I'll just do that so you know. Oops, lost my terminal. There we go. So just to illustrate that clicking run here is the same thing as cargo run, I'm just going to hit cargo run. Please enter an array index. So if we hit 1, it says, and it's asking me for indices, right? So it didn't give me the first index. It gave me the 1 indice, which is actually the second position up here. There's 2, right? Okay, so that's fine. We already did cargo run, so let's use our run button up here just to show that everything's the same. Please enter an array index. So we're going to enter, this time we're going to enter, so let's think about this, right? We have a 0-base index. This is 0, this is 1, this is 2, this is 3, this is 4. So the top indice and the zero-based index is 4. Well, what happens when we enter 5? We had a problem, right? So we had this index out of bounds. The len, or length, len is short for length, of this array, the A array, is 5, but the index, I, is 5. Index out of bounds. The length is 5. Okay, so this is where this sometimes gets confusing, right? Because this is a zero-based index. This is 0. This first position is 0. This first position is, or second position is 1. Second position is 2. Or I'm messing this up. Sorry. The 0 position, the first position is 0. The second position is 1. Third position is 2. Fourth position is 3. Fifth position is 4 as far as indices go. But there are 1, 2, 3, 4, 5 elements here. So the length, even that we see in this inference, is 5. So this error is actually a little confusing, I think, if you're not used to this, right? Because what it's telling us is that the length is 5, but the index is 5. Well, if you're not familiar with zero-based indexing, or that you don't know that this is zero-based index, you'd be like, what the heck? Like, the length of my array is 5, and my index is, and the index I entered is 5, so this should work. But we know this is zero-based index, so 5 is actually not within the bounds of this array. The bounds of this array stop at 4. 4 is the highest indice. Okay. This starts to become, like, very quickly, I think, like, this kind of becomes second nature, in my opinion, because it just, once you understand, it's like there's a length, which is one number, and then there's zero-based index, which means your top, the top indice is likely one number less than your length. And once if you do like standard for loops where you're iterating over array manually, there's better ways to do it in Rust. But if you do it kind of the old-fashioned way that we've done in other languages, where you have an indice and you take a counter and you add a number to it to access every element in an array, you become very familiar quickly with zero-based indexing. And you still need to know it even when we use kind of the better iterators that are in Rust. Okay, well, that's good. I think we've got some good information out of working through that program. So the other thing the book mentions in this section is that we talk about Rust being a safe language, right? And that it's built with the idea of like panics and all this stuff being minimized. But what we're seeing in this instance, when we have the error we just saw, it's a runtime error. And so what that means is during this program that we wrote, we copied it obviously from the book, but if we'd written this on our own or whatever, the Rust compiler didn't recognize, it's not really possible to infer that there's an issue with this, right? That, I guess it's theoretically possible, but the Rust compiler is not aware. When this program is compile time, remember we've talked about this before, compile time and runtime. At compile time, the Rust compiler is not aware that this this index number is going to be passed in as a higher number, because it might not, right? I can come in and type in 3 and it's fine, right? But if I go in, like we've seen, if I type in 68, we get this panic, okay? So that's called a runtime error, because this is happening, this error we're seeing is happening while the program is running, not while it's compiling. I'm hitting this concept of compile time and runtime a lot because if you come from an interpreted language, it's a bit of a mind shift, right? Um, and compiling is a hurdle with Rust sometimes because the Rust compiler and even I guess cargo to some extent helps you. I mean, the Rust compiler is what ultimately enforces like the safety it can into your code, and it can't enforce all safety. But um, there's if you follow people that write Rust normally on Twitter, you'll see them talk about fighting a borrow checker and stuff like that. That's all part of the compiler, and it's because Rust is trying to make your code better. Usually, like I'm sure there's edge cases where you feel like you're you're frustrated with the Rust compiler and what it's trying to do, but in general, like the Rust compiler helps you write better code. Okay, so let's talk about Kogu's question. When, why we should use a tuple data struct. Let's just pull that out, right? I don't know. Just thinking, like, I don't use tuples a lot. I don't, and I don't write a whole lot of Rust either. So let me make that clear. I'm learning it along with everyone else. I think, like, kind of just looking at our example, what maybe maybe I don't know. This is just an idea. What if we wanted to do we could do DOB. Let's do month, name, month, number, and then we could do or we could even do like, I mean, this is pretty contrived, right? Without it being a program, within a program, I don't know that I don't need this. Without it being a program, I don't know that it's going to. But yeah, I mean, that's kind of like what I think. And then like, I I don't know why I would do this, right? But you know, well, it helps if I had some quotation and the month of this is very contrived, Kogu. I'm sorry I don't have a good example for you. And month or so we could do. Oh wait, I didn't even do this right. I like. I'm not all here. I'm not all here today, guys. I'm sorry. Yeah. So I just basically I created a tuple from this tuple. So let's do this. Let's do I'm not sure if this will work, but we'll try it. Yeah. And I did it backwards too, according to my output. Yeah, to be honest with you, Kogu, I I don't write a ton of Rust. You know, I'm learning it as I go with these streams. I haven't really come across a position where I wouldn't actually use a struct instead of a tuple. Um, so like a struct is much more, a struct is kind of almost, it's like a class. If you're familiar with those in other languages. I don't know. Let's do a quick Google. What would I, what are tuples used for in Rust? Um, yeah, so I'm looking at this Rust by example. Let me just get the link to that in the Twitch. I don't know. It actually doesn't really have any good examples in here either. I mean, I think yeah, these aren't really good examples. I think it's an interesting data type. Like, I like that you can destructure it. But yeah, I don't know. I don't know what I would use it for. Yeah, I guess you could use it when you have related data, but don't have or need a label as you do in a struct. Yeah, sorry, this is not a good stream. I'm just like reading now because now I'm curious. Um, yeah, I guess like an anonymous struct kind of, and then you don't storing coordinates. Yeah, yeah, that's a good point. Yeah, yeah, like set ordered data or something like that. Yeah. Cool. It's good to see you, Kogu. I'm gonna wrap up soon, and I'm gonna take a look at what you sent me soon. Cool. Well, yeah, let's not. I'm gonna get going. Thanks for hanging out, Kogu. Thanks if you're watching on YouTube. Please subscribe and like and comment. If you have questions, come into the Grom's Discord and hang out, learn Rust with us. I'm probably gonna do I'll do functions tomorrow. I'll take a few days off for the holidays, spend time with family. I might squeeze in like another Rust and chill because I need to finish up setting up my editor. I realized I didn't install anything for like Toml, so if I go into my cargo.toml file, it's going to complain to me here to install something for Toml. And I also want to get my Vim bindings in because that's really throwing me off. It's ridiculous because I'm not like any kind of Vim master, but I'm now used to it because I have Vim bindings in almost all of my editors. Cool. But that's not really important. Rust and chills are going to be more like less structured. I may rename them because I think we're going to do some other like Solana Web3 stuff, so that'll be fun. But for now, they're called Rust and Chill. Cool. Thanks for watching. Have a good day. GM.